Hello my friends and welcome back to the You Can Do TV channel. In the cast steel valve manufacturing process, wax injection is one of the primary steps for creating valve components. Each component has its own solid pattern or die, crafted to form the necessary shape of the valve. Wax is injected into the pattern, creating a precise mold that represents the final valve component. After the wax patterns are created, they undergo a cleaning process to ensure that all residues and impurities are removed. Heat numbers, which are essential for traceability and quality control, are applied to these wax patterns, and they follow the component throughout the entire manufacturing process. The heat numbers also play a critical role in testing the mechanical properties of the valve components. Along with the wax patterns, test bars are attached, and these bars are subjected to mechanical testing. This data is recorded in Material Test Reports, MTRs, which document the valve's compliance with required standards. Once the wax patterns are prepared, they move to the wax assembly process. In this step, skilled workers attach flow channels, also known as gates, onto the wax components. These gates play a crucial role in controlling the flow of molten metal during the pouring process, ensuring even distribution and minimizing the risk of defects. Along with the gates, risers are also added to the assembly to facilitate the proper flow of metal and prevent shrinkage. Following wax assembly, the components are coated with refractory materials to build a ceramic shell around them. The shell building process typically involves applying between 7 and 9 coats of refractory material. The first few coats are made of ceramically bonded sand, while the later coats include alumina or silica slurry to strengthen the mold. Wire mesh may also be applied for additional reinforcement. Each coat requires dipping into a binder for about 20 minutes, helping to cure and harden the shell. Once the shell building process is complete, the molds are moved to the dewaxing area. In this step, the molds are submerged in a high-temperature solution to melt the wax, leaving behind a hollow ceramic shell in the shape of the valve component. The wax is captured and recycled for future use. With the wax removed, the molds are transferred to baking furnaces. The molds are heated to around 800 degrees Celsius to remove any remaining wax and to strengthen the ceramic shell. The elevated temperature also ensures that the molds are at the optimal temperature for the pouring of molten metal. Heating the molds helps the metal flow smoothly into all parts of the mold, minimizing the risk of shrinkage, voids, or incomplete fills. The molds are loaded into the furnace, and the temperature is slowly increased from room temperature to 800 degrees Celsius over a period of 2 hours. Once the molds reach the desired temperature, they are removed from the furnace and staged for pouring. Each furnace has its own unique heat number, and the metal's chemical composition is closely monitored throughout the process. Once the composition is verified, the molten metal is poured into the prepared molds. For larger diameter valve components, sand casting is often used. This process utilizes a cope and drag mold design, where the pattern, usually made of wood, is placed in a box, and sand is packed around it. After packing the sand, it is hardened using carbon dioxide, and the pattern is removed, leaving a cavity that serves as the mold. This process is well suited for large castings because it can accommodate the large amounts of metal required. The molds are then treated to prevent washing out during the metal pouring process. Cores are placed inside the mold to create hollow sections within the valve. Once the molds are prepared, they are clamped together and ready for metal pouring. After the metal has cooled and solidified within the molds, the castings are taken to the knockout area. Here, the molds are broken apart and the ceramic shell is removed. Gates, risers, and other additional materials are cut off from the castings. The components are inspected and sorted by heat number before moving on to the next stage. Once the castings are removed from their molds, they undergo a series of finishing operations to ensure their quality. Workers grind off any remaining shell material and excess metal to achieve the final dimensions and smooth surfaces. The castings may also undergo heat treatment to improve their mechanical properties. This process involves heating the castings to a specific temperature and then cooling them at a controlled rate to achieve the desired material characteristics. At this stage, castings are inspected visually and dimensionally to ensure they meet the required specifications. If necessary, further non-destructive testing methods. Once the castings have passed inspection, they are sent to the assembly area. First, they undergo a hot water wash to remove any machining oils or dirt. The valve components, such as the wedges and gates, are carefully matched to their respective castings. The valve manufacturing industry plays a crucial role in various sectors such as oil and gas, water treatment, power generation, chemicals, and pharmaceuticals. In 2022, the global valve market was valued at approximately $70 billion, with a projected compound annual growth rate, CAGR, of 6.3% from 2023 to 2030, pushing the market size to nearly $110 billion by 2030. This growth is largely driven by the increasing demand for energy, expanding industrialization, and the rise of automation technologies in various processes. Valves are essential components used to regulate the flow of liquids, gases, and slurries, and their demand is particularly high in industries where precision control over pressure and flow is required. The oil and gas industry, for instance, accounts for nearly 30% of the global valve demand due to its reliance on complex pipeline systems that require durable and reliable valves for safety and efficiency. The water and wastewater management sector is another major consumer, contributing around 20% of the market share, driven by increasing investments in infrastructure improvements. In terms of valve types, ball valves, globe valves, and gate valves are the most commonly used, with ball valves making up 25% of the market. These types are favored for their ability to handle high pressure and temperature applications, as well as their tight sealing capabilities, which are critical in industries like petrochemicals and power generation. Asia Pacific dominates the global valve market, accounting for 40% of the overall share. China and India are the key drivers of this growth due to rapid industrialization and urbanization. Meanwhile, North America and Europe follow, collectively accounting for 45% of the market, with the US leading in innovation and high-quality valve manufacturing. The industry also faces challenges such as the rising cost of raw materials like steel, brass, and copper, which make up 60 to 70% of valve production costs. However, the increasing adoption of smart valves with IoT integration for real-time monitoring is expected to drive future growth. The top-mounted eccentric semi-ball valve is designed with an eccentric valve body, ball, and seat, allowing the valve to self-align during operation. As the valve stem rotates, the closing mechanism tightens, ensuring an increasingly secure seal. A key advantage of this valve is the separation of the ball and seat during movement, which eliminates wear on the sealing ring, a common issue with traditional ball valves. The valve seat, protected by non-metallic elastic material embedded in metal, enhances durability. This type of valve is ideal for applications in the steel and aluminum industries, as well as handling media with tiny solid particles, pulp, coal ash, oil, and gases. It can be installed either vertically or horizontally, making it versatile across different industrial settings. The Lapmaster S250 ball valve lapping system is designed for precise lapping of ball valves with diameters ranging from 100 mm to 250 mm. The system is floor-mounted, making it ideal for workshops and laboratories, and comes ready to use with a full range of features. The ball valve is secured horizontally using a headstock drive system, powered by a variable speed motor. This setup ensures smooth rotation of the ball during the lapping process. Seals are clamped securely and driven by motors, which apply adjustable pressure through pneumatic cylinders. To maintain the spherical shape of the ball and avoid tram lines, the seal assemblies gently rock back and forth while the ball rotates. The machine also features an adjustable lapping arm that sweeps over the ball's surface for an even lap. A syringe pump dispenses precise amounts of lapping compound, ensuring a consistent finish. Operators can control the lapping process via a simple control system, including timers and variable speed drives, to optimize efficiency and precision. The manufacturing of a fully welded ball valve, especially for gas pipelines, involves several crucial steps. First, welding is performed to assemble the valve components, ensuring high strength and leak-proof seals. For a 42 inches valve with a welding thickness of 19 centimeters and nearly 50 tons in weight, arc welding process is used. Next, the stem extension assembly is installed to provide remote operation capability in buried or hard-to-reach areas. Once the assembly is complete, testing is conducted, including pressure and leak tests, to ensure the valve's reliability. Afterward, sandblasting cleans the valve surface, preparing it for coatings. The final step is mounting, where the valve is fitted onto the gas pipeline. Fully welded ball valves are ideal for high-pressure applications like gas pipelines due to their durability and corrosion resistance. The Gorelacker Combi T is a high-production machine designed for manufacturing standing lock seam elbows and reducers. It features two separate workstations, a flanging station and a seam closing station, enabling continuous operation without the need for equipment changeovers, which greatly enhances its flexibility. The machine significantly improves production efficiency by reducing the welding process to just one longitudinal seam, contributing to increased rigidity in the finished product. One of the unique advantages of the machine is its high production speed, maintaining consistent quality throughout operations. It can handle materials up to 1.5 millimeters thick, making it suitable for demanding applications. Additionally, the machine requires minimal maintenance as no lubrication is necessary, thanks to the high-quality construction. All rotating tools are made of hardened steel, ensuring durability and long-lasting performance. The machine is ideal for producing high-quality, rigid seams while operating with minimal downtime due to its robust design. The Auratus factory produces a wide range of products that include over 13 main categories of high-quality special steel castings and forgings. These are vital components in applications that demand superior strength, durability, and resistance to extreme environmental conditions. The processes involved in manufacturing these materials are complex and require highly specialized equipment, technologies, and techniques to ensure precision and consistency. One of the key strengths of this factory is its ability to produce more than 300 different types of forgings and forged pieces. These products include alloy steel, military steel, die steel, pinion steel, bearing steel, roll steel, and stainless steel. Each category of steel offers unique properties that make them ideal for specific industrial applications. Alloy steel is a primary material used for its enhanced mechanical properties, such as improved strength, toughness, and corrosion resistance. It is particularly useful in heavy machinery, where components need to endure high wear and stress. Military steel is a specialized category that meets stringent standards for toughness and impact resistance, making it suitable for defense-related applications, including vehicles, armor, and weapon systems. Die steel is critical for producing industrial dies and molds, known for its hardness and ability to withstand repeated high-pressure applications. Other important products include pinion steel, which is used in transmission and gear systems due to its precise mechanical properties and high wear resistance, and bearing steel, renowned for its hardness and fatigue resistance, making it suitable for applications that involve high rotational speeds and heavy loads. Roll steel and stainless steel are also widely used in industries where both strength and resistance to corrosion are key requirements. The maximum dimensions of the forgings produced can reach a diameter of 1,200 millimeters and a length of 25 meters, underscoring the scale and capability of the forging facility. The company produces a variety of high-precision forging products, such as round bar steel, blocks, rolls, forgings, and hollow stepped shafts. Each of these products is forged with meticulous attention to detail to meet specific industrial needs. For example, the company produces steel tubes with a maximum length of 12 meters, an outer diameter ranging from 500 millimeters to 720 millimeters, and a tolerance of plus or minus 3.5 to 5.5 millimeters. Similarly, the pipes produced have a length of 12 meters, with an inner diameter of 160 millimeters to 500 millimeters, and a tolerance of plus or minus 2.5 to 4.5 millimeters. These specifications highlight the precision required in the manufacturing process, ensuring that each product meets the dimensional requirements of its intended application. The manufacturing process is supported by an extensive range of high-performance forging equipment. This includes 3 sets of 5-ton electro-hydraulic hammers and rapid forging presses with capacities of 800 tons, 1,600 tons, 2,000 tons, and 4,500 tons. This extensive range of forging presses allows the manufacturer to handle a wide variety of materials and forging processes, ensuring flexibility in production. A standout piece of equipment in the facility is the Austrian GFMRF 1000T radial precision forging machine, one of the most advanced in the world. This machine is capable of forging materials with a high degree of precision and speed, making it ideal for producing round, square, flat, and rectangular cross-sections, as well as stepped shafts and thick-walled pipes. Additionally, it can forge specialized products such as non-magnetic drill collars using various forging techniques like hot forging, cold forging, or warm forging. The versatility and accuracy of this machine make it a critical asset in the production of high-quality forged products. In addition to forging, heat treatment is a crucial step in the production process to enhance the mechanical properties of the forged materials. The company operates nearly 50 heat treatment furnaces, including trolley heating furnaces, chamber natural gas heating furnaces, and resistance heating furnaces. These furnaces are used to carefully control the heating and cooling of the forgings to improve their hardness, strength, and toughness. The machining capabilities at the facility are equally impressive, with over 20 large and medium-sized sawing machines capable of handling materials ranging from Phi 100 mm to Phi 1500 mm. The round billet grinding machines have specifications of Phi 80 mm to Phi 800 mm, and the maximum processing diameter of the large-sized horizontal lathe is Phi 1200 mm. Additionally, deep hole drilling and boring machines can process specifications from 600 mm to 1300 mm, and the coreless lathe can handle diameters from Phi 100 mm to Phi 300 mm. These advanced machining capabilities ensure that the forged products meet precise dimensional and quality standards. This is CNC hydraulic die forging hammer forging bevel gear. The new programmable hydraulic die forging hammers with large drop weight, short stroke and fast striking speed, with lower electricity consumption and high production efficiency, compact design and easy maintenance. The section shows how semi-automatic bolt production line work. The steel coil is straightened and fed to the cutter, where the cutter cuts the wire into short pieces. Since this is a semi-automatic line, the worker has to transfer the steel sections after being stamped with round caps into another line to stamp the hexa hats. The excess after stamping the hexagon cap is poured to one side. The semi-finished bolt is poured to the other side. In the next step, these semi-finished bolts will be transferred to another line for threading. And here is the finished product. This is nail aligner with feed conveyor for compact packaging of nails, bolts, and other long, steel parts. Magnetic feed conveyors provide steeply upward sloping transport of ferromagnetic metal parts, such as nails, screws, bolts, or other long steel parts, in the packing industry. The Tesker Model 740 is a powerful two-die thread rolling machine designed for large diameter parts. It offers a rolling force of up to 340,000 pounds, capable of handling parts up to 12 inches in diameter. Equipped with a 75 HP variable speed drive system, the machine ensures precise control over the rolling process. Its digital size control with cycle monitoring and push-button interface allows operators to easily adjust and monitor the rolling process with absolute size readouts. An integrated load balancing crane simplifies spindle assembly and part handling, making setup efficient. In the video, the machine is shown rolling a 4.5-inch TPI single-start Acme thread in 1045 cold-drawn steel, demonstrating the precision and force the Model 740 can deliver. A 20-foot bar handling system is also shown, enhancing part movement during the process. Wheelset Integrated Service is a comprehensive approach to maintaining, refurbishing, and certifying railway wheelsets, ensuring safety, performance, and longevity. The process begins with wheelset disassembling, where the components are carefully taken apart for individual inspection. The axle reprofiling step ensures the axles are machined to the precise dimensions required, restoring them to optimal performance standards. Automated thermal spray repairing is applied to damaged wheel surfaces, allowing for the restoration of the original dimensions and wear resistance. This process helps extend the life of the wheelset components. Next, an axle integrity assessment is performed to check for structural flaws, followed by recertification as new, ensuring that the axle meets all safety and performance standards. For gearboxes, the best gearbox overhaul procedure is defined, involving the cleaning, inspection, and repair of all internal components. A gearbox rotation test is then conducted to ensure smooth and efficient operation under load. Material requirement planning and manufacturing are done on a case-by-case basis, ensuring the availability of the correct parts for each wheelset. Once all components are restored, the wheelset assembly process begins, reuniting all parts to the original specifications. Original wheelset composition is preserved where possible, ensuring the wheelset retains its inherent properties and characteristics. The final step is an automated final inspection and certification, guaranteeing that the wheelset complies with stringent regulatory standards, providing confidence in its performance and safety. Forged pistons are essential for high-performance engines in motorbikes and sports applications due to their superior strength and durability. These pistons are manufactured using AlSi, aluminum silicon, alloys derived from the inverse extrusion of cast aluminum billets. This process refines the material structure, enhancing its mechanical properties over cast pistons. Forged pistons allow for thinner yet stronger sections, which reduces overall weight, crucial for performance applications. To combat wear, particularly in the first groove, hard anodizing coatings can be applied. Additionally, graphite-based coatings are often used on forged pistons to minimize friction between the piston and the cylinder, further improving performance and longevity. The manufacturing process of safety-critical and aesthetically beautiful motorcycle components, such as brake pedals or handlebars, is both intricate and advanced. The journey begins with forging and simulation, where advanced R&D software is used to simulate the forging process. This ensures optimal designs and structural integrity. Brass and aluminum materials, sourced from specialized warehouses, are used for their durability and aesthetic appeal. The forging process is carried out on 15 high-tonnage forging presses, with capacities up to 4,000 tons, ensuring the strength needed for critical motorcycle components. After forging, The components undergo heat treatment to further enhance their strength and durability. The internal heat treatment process, including T4 and T6 treatments, ensures that the metals achieve optimal hardness and resilience to withstand the stresses they will face during use. The machining phase follows, with 17 machining lines featuring fully automated forging presses and state-of-the-art CNC transfer machines, including CNC machining centers. These high-precision systems are essential for producing components with exceptional accuracy, adhering to tight tolerances. This advanced equipment allows for manufacturing flexibility, ensuring that both small and large-scale production runs can be efficiently handled. Assembly is carried out on a semi-automatic line, where components are carefully pieced together. Given the aesthetic importance of motorcycle parts, every component undergoes an aesthetic inspection to ensure its surface finish and design are flawless. The finishing touches, such as polishing or painting, are applied to make the components not only functional but also visually appealing. This sophisticated process ensures that the final motorcycle components are both safe and beautiful, meeting the highest industry standards for performance, durability, and design. Plate rolling machines are essential in the metal fabrication industry, designed to shape and roll flat metal plates into cylindrical or conical forms. The process begins with plate loading, where the flat metal plate is placed into the machine. Once loaded, the plate moves through CNC-controlled feeding, where the computer numerical control system manages the speed and precision of plate movement. Automated plate alignment systems ensure the material is correctly positioned and centered, minimizing any misalignment that could affect the quality of the finished product. High plate pinching power is essential to firmly hold the plate in place as it enters the rolling process. Pinching prevents the plate from slipping during bending, ensuring consistent pressure across its entire surface. The machine then performs pre-bending, a crucial step that allows the machine to bend the plate edges to minimize flat ends. This is particularly important when producing cylindrical or conical shapes. Modern machines can achieve extra small flat parts by exerting powerful pressure during pre-bending, improving the overall curvature. The plate is now ready for precise rolling. Advanced plate rolling machines use multiple rolls to bend the plate into the desired shape, applying uniform force. With simultaneous movements of the rolls, modern machines provide precise plate bending and significantly reduce the need for re-rolling, ensuring efficiency and quality in a shorter time. This also leads to faster production and less machine wear. To handle large and heavy plates, secure side support action prevents the plate from sagging during rolling. High-tech automation systems enhance the machine's productivity, offering very limited involvement of the operator. The machine's software controls most operations, making it highly efficient. The rolling process occurs at high speeds of up to 7 meters per minute, significantly boosting production rates. Furthermore, simultaneous movements of different machine parts reduce the overall rolling time. While the plate is being tack welded, the operator can begin preparing for the next plate to be rolled, ensuring continuous operation and minimizing downtime. After the rolling process, the unloading of the finished rolled can is automated, ensuring safe and efficient handling of the completed cylindrical or conical shapes. With the machine's precise control, the plate edge alignment before tack welding is exact. This precision ensures quality welds that hold the structure together effectively. Additionally, the ability to perform tack welding while the plate is still in the machine further streamlines the process, reducing production time.
Adesso per togliere i due rulli sotto ai fini di tempistica quanto ci vorrà?
This rebar bending machine is designed to bend steel reinforcement bars to desired angles and shapes for use in construction. It consists of a rotating disc with various slots to accommodate different bar sizes. The operator inserts the rebar into the machine and sets the desired angle using an adjustable stopper. When activated, the rotating disc applies pressure, bending the rebar around a fixed pin. This process ensures consistent and precise bends. The machine is typically equipped with a foot pedal or manual control for operation, and advanced models allow for automated bending sequences. Rebar bending machines increase efficiency and reduce labor effort in construction projects like bridges, buildings, and roads. Manufacturing valves is a complex and highly technical process that requires precision, automation, and attention to quality. Companies like Double Lin Valves have embraced advanced manufacturing technologies to ensure that their valves meet global standards for performance and durability. With over 200 employees and a focus on research and development, the company integrates cutting-edge equipment to optimize their production process. Machining automatic special machines. Machining is a critical step in valve manufacturing that ensures each valve component is precisely shaped and finished. At here, machining automatic special machines play a pivotal role in improving efficiency and accuracy. These machines, equipped with manipulators and servo motors, carry out multiple processes simultaneously, using profile cutters to ensure that each product has consistent dimensional accuracy. By automating this part of the process, the company not only increases productivity but also ensures uniformity across all valve components, which is essential for maintaining high-quality standards. The result is a smooth transition from rough or semi-finished parts to finely machined products with minimal errors. Ball automatic special machines. Ball valves are one of the most critical types of valves produced by the company, and the manufacturing process for these requires exceptional precision. The ball automatic special machines are designed to streamline production by shaping critical dimensions in a single-step process, as opposed to the traditional three-step process. This automation reduces the need for clamping and transferring sequences, which often result in misalignment or damage to the product. By using diamond cutter bits, the machines achieve a surface smoothness of raw 0.8, ensuring no leakage even after extensive use. Valve rod special machines. These machines address common issues such as low efficiency and large dimensional errors by integrating advanced automation and upgrading critical systems. The machines process valve rods from raw copper bars with high accuracy, ensuring uniformity and reducing the margin for error. This allows the company to maintain strict quality control while improving production speed and reducing waste. The machines use a one-step extrusion molding process, which significantly reduces the need for manual labor and ensures consistency in the seal ring's dimensions and performance. This automated process not only increases production efficiency but also guarantees that each seal ring is durable, wear-resistant, and smooth, ensuring long-term reliability. 5. Full automatic assembly lines. The final stage of the manufacturing process involves assembling the various components of the valve into a finished product. The facility has introduced full automatic assembly lines imported from Italy, known for their efficiency and precision. These lines are equipped with infrared inspection systems to ensure that each valve is assembled correctly. What once required a team of 13 workers can now be accomplished by a single operator overseeing the automated system. This level of automation reduces human error, increases productivity, and allows the company to meet large-scale production demands while maintaining high quality. This door frame forming machine is designed to efficiently create door frames with decorative patterns. The process begins by feeding corrugated iron sheets into the machine. As the sheets progress, they pass through a series of rollers. These rollers are precisely engineered to gradually emboss the desired pattern onto the surface of the corrugated iron. The continuous motion ensures that the design is consistent and evenly applied across the entire length of the sheet. The rollers not only shape the iron sheet into the required door frame structure but also imprint decorative patterns, enhancing its aesthetic appeal. This automated process ensures high production rates, accuracy, and uniformity, producing door frames that are both functional and visually appealing. Ideal for various architectural and decorative applications, the machine provides a cost-effective solution for large-scale door frame manufacturing with high-quality finishes. The EBAS automatic stirrup production machine processes wire coils in the 6, 5 to 16 mm diameter range. This compact, efficient machine is designed for robust operation, combining ease of use with high output and accuracy. The integral control system ensures precision and fast production. In its fully automatic version, the machine features program-controlled coil settings and an optional automatic wire diameter change for seamless adjustments. An optional 3D bending head enhances its versatility, making it ideal for applications like stair production, where 3D stirrups are essential. This advanced machine helps streamline the production of stirrups, ensuring consistent quality with minimal manual intervention.